All right. Welcome to our second day of Unit 4 of the spring semester PreCal for seniors. So last day of notes, we kind of ended with converting polar points and rectangular points to one another. Now, in this set of notes, we're going to talk about equations. So notice that those four equations that we had earlier are still here, and we're going to use these almost kind of like what we did with our identities unit in the fall semester, where we're going to kind of do some substitution stuff. So if we're going to convert a rectangular equation into polar, our main goal is to get our equation to be r equals, or at sometimes it's going to be theta equals. So rectangular equations have x's and y's, polar have r's and thetas, but either, depending on the equation, would be r equals or theta equals. So if we start here with x equals 3, if you look at that equation at the top, x is the same thing as r cosine theta. Now for this problem, since we have both r and theta, we're just going to solve for r. So in order to do that, I'm going to divide both sides by cosine theta. So honestly, in this class, you could leave your answer as 3 divided by cosine theta. Or some of y'all might not like this divided by cosine. So what's the same thing as dividing by cosine? Well, it's multiplying by secant. So honestly, either of those answers are the same. If you had like a multiple choice test, you would have to know that both these are the same. It's almost like having 1 over root 2 versus root 2 over 2. They're the same answer, just one is in a proper form versus the other. All right, so what about x squared plus y squared? Well, you could replace r cosine theta with x and square it, and you can replace y with r sine theta and square it, and then you would have to do some more identity practice. Or, notice we have an equation where x squared plus y squared equals to r squared. So I'm just going to replace x squared plus y squared with r squared. Like I told you with polar, we have to get this to be r equals, so we're going to square root both sides, and we're just going to get r equals 3. Now, this is a converting equation question. This is not a solving for r. So what I did here is I left this as r equals 3, the positive version, the principal root. If you wanted to, you could have put your answer as negative 3, but most likely we're just going to see r equals 3 instead of r equals negative 3, so that's why I left that answer like that. All right, well, here's another very similar problem where x squared plus y squared equals r squared. Oh, but then I have a y. Well, y, if you look above, is the same thing as r sine theta. Okay, so remember polar equations have only r's and thetas. You can't have any x's and y's in a polar equation, just like you can't have r's and thetas in a rectangular equation. So what's interesting is that with this, we are assuming that we're not talking about a point on the pole, which is the origin point on the rectangular plane. The middle point in the polar plane is called the pole. So we're going to assume that this graph doesn't include the pole. So we can divide both sides by r. And therefore we're left with 4 sine theta, which is something that later on this unit we're going to learn what that looks like as a graph. So it's r equals, we're done. Oh, and then what about this one? Again, you could do some substituting where x equals r cosine and y equals r sine. That's not going to be very helpful. But what you could do here is we can expand this out. So y plus 3 squared is the same thing as y minus 3 times y minus 3. So you end up getting y squared minus 6y plus 9. Again, this y minus 3 squared is the same thing as y minus 3 times y minus 3. So if you FOIL that out, you end up getting something that looks like this. Well, if I move this 9 to the other side, you end up getting x squared plus y squared minus 6y equals to 0. Well, then this is kind of similar to that last thing, where we had x squared plus y squared is the same thing as r squared, and then y is the same thing as r sine theta. But to get this to be r equals, I'm going to move that 6r sine to the other side, so it ends up becoming positive 6r sine. We divide both sides by r, and we get a very similar equation to what we just did. Just had some other algebra work that we had to do. Now this might look a little familiar. This is a line. Uh, this line, if I wanted to quickly sketch it, might look something like this. Okay, not exactly, but it could look something like that, which is going to be important, which we're going to talk about here in a little bit. So we don't have any x squared and y squared, so I can't use r squared, but I do have an x and y, which I can change as r cosine and r sine. Now we need to solve this for r. So since both of these terms have an r, we can factor it out like a GCF. And if I wanted to get this equal to r, I would divide by what it's being multiplied by. So I end up getting 7 divided by 2 cosine theta minus 3 sine theta. And there is nothing more you can do with that. That's as far as you can go. It's not like what we did earlier where it's only over cosine, so I could multiply by secant. You cannot do anything further than this. So leave it alone. Well, this next one, what you could do is you can solve this for y, because what I want you to be able to see is that this is also a line. However, this line is going to go through the origin of the coordinate plane. So it's going to go through here because the y-intercept is 0, and we have a negative slope. So this one's going to be a different line. So again, this is a line, but this one goes through the origin. The previous line did not go through the origin, so they're going to be two different equations. So what I'm going to do here, you could do r sine and r cosine, but what I could do is I can divide both sides by x and find out that y over x is equal to negative root 3, which if you look at the top, what did y over x equal to? Well, tangent. So now I'm down to this. And there might be times where you could leave it like that, but the directions for writing polar equations is that it's r equals or theta equals. So in order to get this to be theta equals, you have to do tangent inverse. So if you're asked to do this, you can either give it to me in radians or degrees. But if I ask you for tan inverse, or the inverse tangent of negative root 3, you need to make sure that you give me the rainbow value, which is going to be negative 60 degrees. Or again, you could have told me in radians, negative pi over 3, just, it doesn't matter, same answer. So, but it's not positive 60 degrees. Positive 60 degrees would have been a line that kind of has a positive slope. This has a negative slope, so it was negative 60. All right. So this could be a little challenging, but again, practice it. It's kind of the same thing, just different numbers every single time. But what is the other way of doing this? So the other way of doing this is going from polar to rectangular, which rectangular has x's or y's. And depending on the equation, kind of depends on how you write it. So r equals 9 secant theta. Well, that kind of is similar to what we did earlier, where if I want to get secant to the other side, I could divide both sides by secant, or what happens if I multiply by its reciprocal? Well, secant times cosine is 1. So I need to do the same thing on the right-hand side. So we end up getting r times cosine theta equals 9, which r cosine is x, and that's it. That's the rectangular version of that polar equation. But what about number 8 here, this next one? I could multiply both sides by secant, but then I would have r secant theta, which is not one of the formulas that we have on the top. So this is another thing that we do. What would be nice is if there was an r in here. Well, I could do that by multiplying both sides by r. So r times r is the same thing as r squared. Well, r squared is one of those formulas at the top where it said it was x squared plus y squared. And r cosine is the same thing as x. So just to make sure that everybody's kind of answer is the same, what we ask is if you have any of these variables squared, what we would do is get it equal to 0. So x squared plus y squared minus 4x equals 0. And that's just something that we like to do in this class. All right, theta equals pi over 6. This is kind of like that last problem that we did with the converting from rectangular to polar. This is a line. This line would go through the origin. So in a problem like this, there's only one equation at the top when we're doing with converting that has a theta in it, and it's tangent theta. Well, if I'm going to tangent the left side, I need to tangent the right-hand side. So tangent of theta is the same thing as y over x. Tangent of pi over 6 is one of those unit circle questions, or if you want to do tangent of 30, in my head, I remember that as root 3 over 3. So this is a line. Equation line should be y equals. So I'm going to multiply both sides by x and end up getting root 3 over 3 x. As y equals root 3 over 3 x is my line. All right, number 10 is very similar to what we did with number 8. What would be nice is if I had an r here and an r here. Well, in order to do that, I would have to multiply both sides by r. So you end up getting r squared equals 2r cosine theta minus 2r sine theta. Well, r squared is x squared plus y squared. R cosine is x, r sine is y. And again, in this class, we ask you that if you have x and y squared, just move everything to one side and get it equal to 0 so that it's the same for everybody. You're not asking yourself like, oh, well, or can this be an answer on the answer key? Like, I'm going to probably have something that looks like this. So those are the type of equations that you'll see in this class. There might be some challenging ones in the assignment, but that's for you to practice and ask questions if you are struggling. So good luck.